the same way we solve quadratic equations, either by factoring or by factorization, or either by quadratic equations or by completing a square method, is the same way we solve quadratic inequalities. Quadratic inequalities are solved much easier by sketching a graph to identify the range of values of x or the unknown which satisfy these inequalities. For example, let's start. In general, quadratic inequalities, they look similar or almost identical to quadratic equations, which means in general they are in the standard form of ax squared plus bx plus c, then follows either any quadratic symbol, either greater than or equal to 0, like that. So they are not quadratic equations because they have an inequality symbol here. That's why they are quadratic inequalities. So how do we solve them? Let's start with example 1. Two x squared minus 3x minus 2 is greater than or equal to 0, right? So first thing to do is to look on the quadratic function, this expression first. Let's factorize that, or let's treat this inequality the same way we would have treated the equation. We are just assuming that there is an equal sign which you are used to deal with. Solve this, find the roots of this function. So what we are going to do is we are going to say 2 times negative 2, that's negative 4x squared. If we multiply the first and the last, we're going to get negative 4x squared. And we look for the factors of negative 4x squared that can be added to the middle term, which is negative 3x. So carefully, I think that's 1 and 4, but one of it must be negative, which is this 1 times this, we're going to get negative 4, and if we add this, it's gonna be negative 3. So we're gonna replace the middle term by this value, so it's going to be 2x squared plus 1x minus 4x minus 2 is greater than or equal to 0. Therefore, we do factorization by grouping. Common factor here is x. We're going to left with 2x plus 1. And the common factor here is negative 2. We're going to left with negative 2 into negative 4x, going to be 2x. Negative 2 into negative 2, that's going to be positive 1, greater than or equal to 0, like that. And then the next thing to do is to take, since this bracket and this bracket are the same, it means you're doing it correctly. So 2x plus 1 in one bracket, and in the other bracket we're going to put the scalars, or these ones, the common factors. We factorized it first, so it's going to be x minus 2 into this bracket is greater than or equal to 0. So if we are to solve this, we are assuming that we want to find the root, right? So look, we are assuming that there's an equal sign here, just to sketch we want to find the roots that we are going to use to sketch the graph. So we're going to have 2x plus 1 and x minus 2 is equals to 0. And then look, either one of these is going to be equal to 0. So if it's 2x plus 1 is equals to 0, or x minus 2 is equals to 0. What it means is 2x is equals to -1, or x is equivalent to negative half, pardon me on that, negative half, or here x is equals to +2, right? So what we're going to do is we are going to use these roots to sketch the graph. So now it's time we have to sketch the graph, right? This is the very important part. Look carefully, right? This is the left-hand side we are dealing with. I will explain a little bit more. Look carefully. If I sketch this quadratic, it's going to look like this. We're going to have, what matters the most is where it cuts the x-axis, which means the roots or the solutions. So if x is equals to -half, it's 0 here, so half is on this side. Or x is equals to +2, which means x is on this side, which is 2 here. So definitely our graph is going to be a cup-shaped or a U. It's going to be a U-shaped because we have a positive leading coefficient here. So if we have a positive leading coefficient, our graph is going to look this way. If it was negative, it's going to look this way. If it was a negative, it was going to face up. So unfortunately, it's a U-shaped. So which means our graph is going to be this. That's what it's going to do. So that's our y-axis. Remember, our y-axis is also called x is equals to 0. That's the equation for y-axis because it cuts x-axis at 0. And we should also know that our x-axis is also called y is equals to 0 because it cuts y-axis at 0 as well. So here's the thing. This is our f of x, which means our function, which is this part. So now, how do we find the range of values that satisfy this inequality? Here's the thing. They said, according to the question, look what they said. They said this function is greater than 0. Remember, this 0, it simply means y is equals to 0. Because in general, our function is written in terms of y is equals to ax squared plus bx plus c. So here what happened is, you're going to see this, our left-hand side is equals to this. So this y is the one replaced by 0. That's why we have a 0 here. So that's going to be something like ax0 is equals to ax squared plus bx plus c. Now, if you look very careful, so how they structure our inequality is this way. They make sure that you are going to understand that we have this function y is equals to 0 is going to be less than this function. So y is equals to 0 is our x-axis here. So they are saying in this question, our x-axis, the function part that the solutions of the functions they want is the part where it's greater than our x-axis, where it's y is equals to 0, which is our x-axis. So greater than, when the function is greater than 0, it simply means where the function is above the x-axis. Because look, this is the y is equals to 0. So the function is above any value that is above, that is greater than y is equals to 0 is above, which is this part, the red part I just showed. So which x values satisfy this? So you're going to see the x values that satisfy this are these ones. From here, going this side, these in blue, these are the x values which satisfy where it's above. Because if I put any value here, if I go up, it's above. It's not anything below, it's above. So these are the x values that satisfy this. So which simply means now, on the solution of this quadratic, we are going to say, okay, the x value is less than or equal to, from here that's where it's above, or equal to negative half. Why do I say or equal to? Because in the question it's included. Here you can see in the question it's included. So we can also say and the values of x where x is greater than or equal to 2. Do you get the sense? That's where the x is, the x values, the range of x values that satisfy the part of the graph that is above. Do you get the sense? Right, let's try it again on example 2 to see, so that you can perfect your understanding on this. Example 2. Example 2. In our example 2, we're going to have the question says, find the range of values, find the range of x for which x squared minus 6x minus 7 is less than 0, right? The same way we have done with the first equation, the first example, is the same way we are going to solve this one as well, right? X squared minus 6x minus 7 is less than 0. Therefore, 7 and 1, which simply means we're gonna got, if we factorize this, we're gonna have x minus 7 and then x plus 1, right, is less than 0. So which simply means if I'm to find the roots are going to be either x minus 7 is equals to 0 or x plus 1 is equals to 0. So x is either positive 7 or x is either negative 1. So what we're going to do is to sketch the graph to determine the inequalities we put in between these two, because the question is not in an equation form, is an inequality form. So we're going to sketch our graph again, right, where x is equals to 7 is this side, where 0 is here of our x-axis, and our y-axis where it's negative 1 somewhere here. And in this particular moment, it's also positive. So our graph is going to look like this as well. This graph is not drawn up to scale. It's just a sketch, right? And they say this graph, they want the part where it's less than 0. When the function is less than 0, it simply means it's below the x-axis. They want the part where it's below the range of x values, where the graph is below the x-axis. You get the sense? Because the x-axis, the y is equals to 0. So which means they are saying this part of the graph is less than y is equals to 0. To get the sense? And y is equals to 0 is our x-axis. So if this whole part, for it to be true, what values of x should we put in so that the inequality will remain true, so that the left-hand side will be smaller than 0, which simply means these values, they are below x-axis, which is y is equals to 0. So you're going to say, you're going to realize that in this particular moment, we have the values that are x on the solution, on this one. We're going to have x is greater than x is greater than -1, and the values of x which are less than 7. I'm not saying equal to, because in the question there is no equal to effect. So if you look careful, these values are these ones here, and we'll indicate them with a blue marker on the graph. These are the x values that are needed. These ones are the x values that are needed by the equation. So these ones, if they are like this, they can be, you can write this together because they are not diverging, right? So we're going to say x is going to be, you're going to say this x here is satisfying all values that are less than 7, and this side is all values that are greater than -1. So x is greater than -1 and x is less than 7. Then boom, we are done here.